Good morning and welcome to this session. We're going to start module 4. In module 4, we are going to cover the following topics, that is sequential circuit design. In particular, we'll see how to design a synchronous counter, mod n counter, uh, that would be using clock JK flip-flop, clock D flip-flop, clock T flip-flop, and clock SR flip-flop. And also we're going to study about Mealy and More models. We'll also see how to construct state diagrams. Okay, so this is what we are going to cover in module 4. Now, coming to the design of a counter. To design a counter, we would, okay, say if I had to design a counter for mod n, okay, mod n. Now, mod n would indicate how many states it would represent. Okay, now if I say mod 4 counter, if I say mod 4 counter, it would, and if we consider to be up counter, it would count 0, 1, 2, 3. Okay, it would count 0, 1, 2, 3. Okay, now to represent these, how many digits we would require? 3 is the biggest number. To represent 3, 2 bits are sufficient, meaning the binary representation would be 0, 0, 0, 1, 1, 0, and 1, 1. So there are only two states in each output, meaning what? You would require only two flip-flops. For any design, first thing that we consider, okay, first thing that we should consider is to decide on how many flip-flops we would require. Okay, first step is to determine the number of flip-flops required. Okay, determine the number of flip-flops required. Second step is to decide on what type of flip-flop you're gonna use. Okay, choose JK, SR, D or T flip-flops. Right? Yes? No?
Yes, sir.
Okay. Third step is to write write the excitation table. Fourth is draw K map and get equation. Okay. 5 is draw the final circuit. So these are the steps that are required to design any counter. Okay. These are the steps that are required to design any counter. Now, if you remember in yesterday's session, we were discussing about registers, shift registers, serial in, parallel out shift registers, which can be used for counters. And what flip-flop we used there? We used D flip-flop. Meaning what? We use flip-flops, and to make them work for a certain mod counter, up counter or down counter, what we do, we are going to have flip-flops with that some logic network. We used an AND gate, if you remember. We used AND gate and we connected it to a particular input of a flip-flop. So that is what we are going to do. We have one flip-flop. The input to the flip-flop would be fed from the logic network, which would decide what value it should feed to get the next output. Okay, and also the previous output, which I have marked here in orange, is going to be fed back to the logic network. I hope you understood this point.
Yes, sir.
Okay, next that we need to know is the excitation table for different flip-flops. Okay. Okay. Now, what do you mean by excitation table? Meaning, I have a present state, I have a next state. Earlier, we would represent this as Q and this as Q plus. Correct? My present output is Q. The next output that I am going to get is Q plus. That is how we represented. Meaning, okay. Now, say, assume my present state is 0. My next state is 0. My present state is 0. Next state is 1. 1, 0, 1, 1. Okay. Now, for J and K. ಅರ್ಥ ಏನು, ನಾನು ಜೆ ಅಂಡ್ ಕೆ ಏನ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ರೆ ಝೀರೋ ಇರೋದು ಝೀರೋ ಆಗೇ ಇರುತ್ತೆ ಅನ್ನೋದು ಈ ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ನಮಗೆ ಹೇಳುತ್ತೆ. ಓಕೆ, ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ಡ್ರಾ ಒನ್ ಲೈನ್ ಹಿಯರ್. ದಿಸ್ ಶುಡ್ ಹೆಲ್ಪ್ ಅಸ್ ಫಾರ್ ಅ ಲಾಂಗ್ ಟರ್ಮ್. Meaning, I say that if Q is 0, Q plus is 0, if I give J value as 0 and K as don't care, whatever is the value for K. Okay, if you remember JK flip-flop, remember JK flip-flop, what are the conditions? You had 0, 0. When J is 0, K is 0, it has no change. When J is 1, K is 1, it was 1, 0. When it was 0, 1, it was 0, 1. Correct? Yes or no?
Yes, sir.
Okay, so using that flip-flop table, okay, using that flip-flop table, we can deduce to this condition. For 0 to 1, J should mandatorily be 1 and K can be don't care. For 1, 0, for 1, 0, it is don't care 1. For 1, 1, it is don't care 0. Just give me a minute. I'll try to pull out the truth table that we have used for JK flip-flop. So flip-flops, we did it where? Module 3, right? Let me try to get the sheet that we used for flip-flops for J and K. Yes, here we go. Now, whatever I'm showing you is for master slave JK flip-flop. Okay, for master slave JK flip-flop. Correct? ಈ ಶೀಟ್ ನೀವು ನೋಡಿದ್ದೀರಾ?
Yes, sir.
Yes, sir.
ಓಕೆ, ಇವಾಗ ಈ ಟೇಬಲ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. When J is 0, K is 0, if Q is 0, Q plus is 0. Okay, so we'll try to highlight 0, 0 condition. ಅಂದ್ರೆ ಏನು? Q 0 ಇರಬೇಕು, Q ಬಾರು 0 ಇರಬೇಕು. Correct? These two are the conditions. Correct?
Yes, sir.
See,
Yes, sir.
irrespective of K value, if J is 0 and Q is 0, output is 0. Correct? ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ನ ಹೆಂಗೆ ಡಿರೈವ್ ಮಾಡ್ತಾ ಇದೀವಿ ನೋಡಿ. ಜೆ ಕೆ 0 ಇರಬೇಕು, ಕೆ ಡೋಂಟ್ ಕೇರ್, ಕೆ ವಾಟ್ ಎವರ್ ಇಟ್ ಇಸ್. ಇಫ್ ಕ್ಯೂ ಇಸ್ 0, ಕ್ಯೂ ಪ್ಲಸ್ ವಿಲ್ ಬಿ 0. ಕರೆಕ್ಟಾ?
Sir.
ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಐ ಟ್ರೈ ಟು ಮಾರ್ಕ್ ಇಟ್ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಕಲರ್. 0 0 ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ 0 1, ಇಲ್ಲಿ 0 ಇದೆ, ಇಲ್ಲಿ 1 ಹೋಗಿದೆ, ಇಲ್ಲಿ 0 ಇದೆ, ಇಲ್ಲಿ 1 ಹೋಗಿದೆ. ಕರೆಕ್ಟಾ? ಅಬ್ಸರ್ವ್.
Yes, sir.
Observe, J should be 1 and K is don't care. J should be 1 and K is don't care. You will get 0 1. Correct? Understood the concept? Well, please respond. ಇವಾಗ ನೋಡಿ, Q is 0, Q plus is, sorry, Q is 1, Q plus is 0. Q is 1, Q plus is 0. ಇದರಲ್ಲಿ ಏನು ಕಾಮನ್ ಇದೆ ನೋಡಿ, K should be 1 and J is different, so don't care. J don't care, K is 1, so output 1 ಇದ್ರೆ 0 ಆಗತ್ತೆ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ?
ಎಸ್ ಸರ್.
ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ನ ಹೆಂಗೆ ಡಿರೈವ್ ಮಾಡೋದು ಅಂತ ಅರ್ಥ ಆಯ್ತಾ ಕಾನ್ಸೆಪ್ಟ್? ಇನ್ನ ಒಂದ್ ಮಾಡ್ಬಿಡೋಣ. ಲಾಸ್ಟ್ 1 1 ಕಂಡೀಷನ್ ನೋಡಿ, Q is 0, Q plus is 1, Q is 0, Q plus is 1. ಏನ್ ಕಾಮನ್ ಇದೆ ನೋಡಿ, K 0 ಇದೆ, K 0 ಇದೆ, J ಡೋಂಟ್ ಕೇರ್, ಆವಾಗ 1 1. ಅರ್ಥ ಆಯ್ತಪ್ಪ ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ಹೆಂಗ್ ಬರೆಯೋದು ಅಂತ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಯ್ತಾ ನಿಮ್ಗೆ?
ಎಸ್ ಸರ್.
ಓಕೆ. ಸೊ ಇದೇ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ನಾವು ಏನ್ ಮಾಡ್ತೀವಿ, ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ಸ್ ಬರಿತೀವಿ. ಸೊ ದಿಸ್ ಇಸ್ ಫಾರ್ ಜೆ ಅಂಡ್ ಕೆ. ಸಿಮಿಲರ್ಲಿ ಫಾರ್ ಎಸ್ ಆರ್ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್, ಸಿಮಿಲರ್ಲಿ ಫಾರ್ ಎಸ್ ಆರ್ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್.
Sir,
Yes sir.
what is the use of this excitation table, sir?
Just give me 2 minutes. We'll finish off this and then I'll tell you how we are going to use this. Okay. Okay. Now observe, when S is 0 and R is don't care, we will get 0 0. When S is 1 and R is 0, set ಅಂದ್ರೆ ಔಟ್ಪುಟ್ 1 ಆಗಬೇಕು, ಔಟ್ಪುಟ್ 1 ಆಯ್ತು. ಸಿಮಿಲರ್ಲಿ ಫಾರ್ 1 0 ಇಟ್ ಶುಡ್ ಬಿ 0 1. ಫಾರ್ 1 1 ಡೋಂಟ್ ಕೇರ್ 0. If you observe, for SR flip flop you will not get 1 1 condition because it is invalid. So SR flip flop ಗೆ excitation table ಇಲ್ಲಿ ಬರ್ತಿದ್ದೀವಿ. ನೆಕ್ಸ್ಟ್ ಡಿ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ ಬರೆಯೋಣ. ಓಕೆ, ಡಿ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್. ಡಿ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ ಏನು ಒಂದೇ ಇನ್ಪುಟ್ ಇದೆ, ಪ್ರೆಸೆಂಟ್ ಸ್ಟೇಟ್ 0, ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ 0. ಸೊ ಡಿ ಇನ್ಪುಟ್ ನಾವೇನ್ ಕೊಡ್ಬೇಕು ಅವಾಗ 0. ಕರೆಕ್ಟಾ? ಸೊ ನಾವೇನ್ ಇನ್ಪುಟ್ ಕೊಡ್ತೀವಿ ಅದೇ ಔಟ್ಪುಟ್ ಬರುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ. ಸೊ ಇರ್ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಫ್ ದ ಪ್ರೀವಿಯಸ್ ಸ್ಟೇಟ್. ಸೊ ಡಿ ಎಸ್ 0 1 0 1. ಕರೆಕ್ಟಾ? ಅರ್ಥ ಆಯ್ತಾ? ಕಾನ್ಸೆಪ್ಟ್ ಇಸ್ ಕ್ಲಿಯರ್?
Yes, sir.
Okay. Now at last we will see toggle flip flop. Toggle flip flop concept ಏನು? When the T input is 0, when the T input is 0, output will not change, meaning output will remain same. So for the first and last condition, input should be 0. 0 ಇಂದ 1 ಆಗಬೇಕು ಅಂದ್ರೆ ಟಾಗಲ್ 1 ಇರಬೇಕು, 1 ಇಂದ 0 ಆಗಬೇಕು ಅಂದ್ರೂ ಟಾಗಲ್ 1 ಇರಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ಹೆಂಗ್ ಬರಿತೀವಿ ಅಂತ ಗೊತ್ತಾಯ್ತಾ?
ಸರ್ ನಾವು ಬರೀ ಔಟ್ಪುಟ್ ಬರಿತಾ ಹೋಗ್ತೀವಿ ಅಲ್ವಾ ಸರ್ ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ಅಲ್ಲಿ?
ಹೌದು, ಔಟ್ಪುಟ್ ನೋಡ್ಕೊಂಡು ಆ ಔಟ್ಪುಟ್ ಬರೋದಕ್ಕೆ ಏನ್ ಇನ್ಪುಟ್ ಕೊಡಬೇಕು ಅಂತ ನಾವು ಬರಿಬೇಕು. ಓಕೆ, ಇದನ್ನ ಒಂಥರ ನಾವು ರಿವರ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಇದ್ರಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇವಾಗ ಕರೆಂಟ್ಲಿ ಔಟ್ಪುಟ್ ಇದಿದೆ, ಕರೆಂಟ್ಲಿ ಔಟ್ಪುಟ್ 0 ಇದೆ. ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ನನಗೆ ಔಟ್ಪುಟ್ 1 ಬರಬೇಕು ಅಂದ್ರೆ ನಾನು ಏನ್ ಇನ್ಪುಟ್ ಕೊಡಬೇಕು? ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ
Yes, sir.
ಆಯ್ತಾ?
Ha, sir.
Yes. See, this is very important. If you don't understand this concept, whatever I have written here, going forward, you will not know how to design the counters. I will give you 1 minute time. Please write down this excitation table very neatly. Don't make any mistakes. This table ಟಿಪಿಕಲ್ ಆಗಿ ಬೇರೆ ಕಡೆ ಎಲ್ಲ ಏನ್ ಮಾಡ್ತಾರೆ, ಸಪ್ರೇಟ್ ಟೇಬಲ್ ಬರೆಸ್ತಾರೆ. ನಾನು ಎಲ್ಲ ಒಂದೇ ಕಡೆ ಬರ್ಸಿದೀನಿ, ಸೊ ದಟ್ ನಿಮ್ಗೆ ರೆಫರೆನ್ಸ್ ಒಂದೇ ಕಡೆಗೆ ಸಿಗತ್ತೆ ಅಂತ. ಓಕೆ, okay, please write down this table very neatly without making any mistakes. So somebody was asking about application table or excitation table in the beginning. I hope they are referring to the same thing, right? Done writing? Okay, now we'll see how to design a counter using this. Okay, we will see how to design a counter using this. For the first, we will design using JK flip-flop. Using JK flip-flop, we will design a mod 6 counter. So the question in your exam could be something like this. Design a mod 6 up counter using JK flip-flop. Design a mod 6 up counter using JK flip-flop. So first step ಏನು ನಿಮ್ಗೆ? mod 6 ಅಂದಿದ ತಕ್ಷಣ ಏನಾಗತ್ತೆ? mod 6 ಅಂದ್ರೆ ಎಷ್ಟು? mod 6 ಅಂದ್ರೆ
0 to 5.
So we need 3 bits.
yes, very good. So first step is mod 6 will count from 0 to 5 in decimal, meaning we would need from 000 to 101, correct?
Yes, sir.
So therefore number of flip-flops required is equal to 3. First step ಬರ್ಕೊಳ್ಳಿ, ಓಕೆನಾ? ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಏನು? ವಿ ಹ್ಯಾವ್ ಟು ಡಿಸೈಡ್ ವಾಟ್ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ಅಂತ. ಕ್ವಶನ್ ಅಲ್ಲೇ ಕೊಟ್ಟಿರೋದ್ರಿಂದ ವಿ ವಿಲ್ ಯೂಸ್ JK ಫ್ಲಿಪ್ ಫ್ಲಾಪ್. ವಿ ವಿಲ್ ಯೂಸ್ JK ಫ್ಲಿಪ್ ಫ್ಲಾಪ್. ನನ್ನ ಪೆನ್ಸಿಲ್ ಅಲ್ಲಿ ಬರೆಯೋದು ಕಾಣಿಸುತ್ತಪ್ಪ ನಿಮ್ಗೆ?
Yes,
ಸರಿ.
sir.
ಇವಾಗ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಏನು? ನಾವಿಲ್ಲಿ ಬರ್ದಿದ್ವಿ ಅಲ್ವಾ? ಥರ್ಡ್ ಸ್ಟೆಪ್ ಇಸ್ ಟು ರೈಟ್ ದ ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್. ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ಕಿಂತ ಮುಂಚೆ ಟ್ರೂತ್ ಟೇಬಲ್ ಬರೆಯೋಣ. ಹೆಂಗೆ ಅಂದ್ರೆ, ಇವಾಗ 3 ಬಿಟ್ಸ್ ರಿಕ್ವೈರ್ಡ್ ಅಲ್ವಾ? ಎಸ್ ಆರ್ ನೋ? ಓಕೆ,
Yes, sir.
ಸೊ 3 ಬಿಟ್ಸ್ ಅಂದ್ರೆ ರೈಟ್ ಪ್ರೆಸೆಂಟ್ ಸ್ಟೇಟ್ Q1, Q2, Q3, right? Next state Q1 plus, Q2 plus, Q3 plus. ಓಕೆ ಹಾ ಒಂದು ನಿಮಿಷ.
ಸರ್ ಸ್ಕ್ರೀನ್ ತುಂಬಾ ಬ್ಲರ್ ಆಗಿದೆ.
Yes, give me a minute. That is more to do with the angle. The rotation changed. This one is very tricky actually. Give me a minute. Let us see if yes, this changed. Fine. How about now?
Okay, sir.
Great. So we'll continue writing. So counter will start from 0, 0, 0. Present state. What should be the next state? From 0 it should go to 1. 0, 0, 1. 0, 0, 1 ಇದ್ದಾಗ 0, 1, 0. 0, 1, 0 ಇದ್ದಾಗ 0, 1, 1. 0, 1, 1 ಇದ್ದಾಗ 1, 0, 0. 1, 0, 0 ಇದ್ದಾಗ 1, 0, 1. 1, 0, 1 ಇದ್ದಾಗ ಏನಾಗಬೇಕು? Again it should go back to state 0. Correct?
Yes, sir.
Okay. 1, 0, 1 ಆದ್ಮೇಲೇನು 1, 1, 0 ಇದ್ದಾಗ ಔಟ್ಪುಟ್ ಡೋಂಟ್ ಕೇರ್. 1, 1, 1 ಇದ್ದಾಗ ಔಟ್ಪುಟ್ ಡೋಂಟ್ ಕೇರ್. ಈ ಟೇಬಲ್ ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ಓಕೆ, ಇವಾಗ ಏನ್ ಮಾಡ್ಬೇಕು ನೀವು? ಈ Q1 Q1 ಪ್ಲಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, Q2 Q2 ಪ್ಲಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, Q3 Q3 ಪ್ಲಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಇದಕ್ಕೆ JK ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ದು ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ನಾನು ನಿಮ್ಗೆ ಏನ್ ಹೇಳ್ಕೊಟ್ಟಿದ್ನಲ್ಲ ಅದ್ರ ಪ್ರಕಾರ ಇನ್ಪುಟ್ಸ್ ಬರೀಬೇಕು ಇವಾಗ. ಸೊ ನಾನು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀನಿ, J1 K1 ಅಂತ ಬರಿತೀನಿ. ಓಕೆ, J1 K1 ಅಂತ ಬರಿತೀನಿ. ಚೂರು ಲೈನ್ ಹಾಕೊಳ್ಳೋಣ. ಓಕೆ, ಇವಾಗ ನಾವಾಗಲೇ JK ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ಗೆ ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ಬರ್ದಿದ್ದೀವಿ. 0, 0 ಇದ್ದಾಗ J ಅಂಡ್ K ವ್ಯಾಲ್ಯೂ ಏನು? 0, ಡೋಂಟ್ ಕೇರ್. ಕರೆಕ್ಟಾ?
Yes, sir.
0, 0 ಇದ್ದಾಗ ಮತ್ತೆ 0, ಡೋಂಟ್ ಕೇರ್. 0, 0, 0, ಡೋಂಟ್ ಕೇರ್. 0, 1 0, 1 ಬಂದಾಗ 1, ಡೋಂಟ್ ಕೇರ್. 1, 1 ಬಂದಾಗ ಡೋಂಟ್ ಕೇರ್ 0. This I am writing from the excitation table that we have written earlier. 1, 0 ಇದ್ದಾಗ ಡೋಂಟ್ ಕೇರ್ 1. 1, ಡೋಂಟ್ ಕೇರ್ ಇದ್ದಾಗ say here I don't really have to bother, I'll just write X6. ಯಾಕಂದ್ರೆ ಆ ಕಂಡೀಷನ್ ನನಗೆ ಬೇಕಾಗೇ ಇಲ್ಲ. ಕರೆಕ್ಟಾ?
Yes, sir.
ಈ ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲಿ ತನಕ ಅರ್ಥ ಆಗಿದೆಯಾ ನಿಮ್ಗೆ? ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು. ಅಂಡ್ ಯೂಶಲಿ ಈ ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ಬಂದ್ರೆ ನಿಮ್ಗೆ 8 to 10 ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ. ಓಕೆ, J1 K1. ಅದೇ ತರ J2 K2. J2 K2 0, 0 ಇದ್ರೆ 0x. 0, 1 ಇದ್ದಾಗ 1x. 1, 1 ಇದ್ದಾಗ ಏನ್ ಬರಿಬೇಕು?
X0.
ವೆರಿ ಗುಡ್, X0 ಬರಿಬೇಕು. 1, 0 ಇದ್ದಾಗ
X1.
0 0 0 x 0 0 is 0 x. These two are don't care. ಅದೇ ತರ J3 K3 J3 K3 ನೀವು ಬರೀತೀರಾ ಪ್ಯಾರಲಲ್ ಆಗಿ ಬರೀತೀರಾ
Yes, sir.
ಸೊ 0 1 0 1 ಇದ್ರೆ 1 x 1 0 is x1 0 1 is 1x. ಯೂಶಲಿ ಇದೆ ತುಂಬಾ ಈಸಿ. Okay, you can write this as present state, next state, inputs or flip-flop inputs. ಇಷ್ಟು ಬರ್ದಾಗಿದೆಯಾ?
ಬರಿತಾ ಇದೀವಿ.
ಹಾ ಬರೀರಿ. Those who have done writing, I want you to draw 1, 2, 3, 4, 5, 6 K maps for 3 variable input. 6 K maps for 3 variable input. 3 variable ಅಂದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? 8 ಸೆಲ್ ಬರುತ್ತೆ. ಓಕೆ, just write this and keep it ready. I can take this as Q1, can take this as Q2, Q3, 0 1 0 0 0 1 1 1 1 0 0 0 0 0 0 0 0 0 1 is 1 2 3 4 5 6 7. Done writing? You have to be quick in this. ಆಯ್ತಾ? ಎಕ್ಸೈಟೇಷನ್ ಟೇಬಲ್ ಬರ್ದಾಯ್ತಾ?
Yes.
ಓಕೆ, ಇವಾಗ ಅಬ್ಸರ್ವ್
Yes, sir.
ಮಾಡಿ, ನಾನು ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ದೀನಿ ಅಂದ್ರೆ ಐ ಹ್ಯಾವ್ ಟೇಕನ್ Q1, Q2, Q3 as inputs. Why? If you observe, look at this diagram here. Q1 bar Q2, Q2 bar, Q3, Q3 bar will act as inputs. Present output will act as input to the next stage. Okay, so what we have to do is we have to compute for J1. Okay, so J1 is equal to ಇಲ್ಲಿಂದ ಬರ್ಕೊಂಡು ಹೋಗೋಣ. Okay, for 0 it is 0, for 1 it is 0, for 2 it is 0, for 3 it is 1. Okay, rest and all is don't care condition. For rest it is don't care condition. This is the grouping for it. So J1 is equal to what you will get? Q2, Q3. Okay, J1 is equal to Q2, Q3 is what you will get. Correct ಅಪ್ಪ?
Yes, sir.
ಅರ್ಥ ಆಯ್ತಾ ಕಾನ್ಸೆಪ್ಟು? ಇವಾಗ ಅದೇ ತರ K1 ಗೆ ಬರೀರಿ. ಅದೇ ತರ K1 ಗೆ ಬರೀರಿ. K1 ಗೆ ಬರೆದಾಗ don't care, don't care, don't care, don't care. 4 don't care, then 0, then 1, then XX. What you can do is safely you can put XX here for all by default. Okay, now if you group this, you can see you can pair, you can form a quad, not a pair, a quad. So you can tell K1 is equal to Q3. ಅರ್ಥ ಆಯ್ತಾ? ಅದೇ ತರ J2, K2 ಬರೀರಿ ಪ್ಲೀಸ್. I'm writing for J2 0 1 X X, then you get 0 0 XX. For K2 this is for J2, J2 is equal to ಅಂತ ಬರೀತೀನಿ ಇಲ್ಲಿ. X X 0 1, right? Similarly J3 1x 1x 1x. Here I can form these two into one group, correct? Here these four will form one group. Here this entire thing will form one octane. Okay, so K2 is also equal to Q3. For this it would be it is going to be Q1 bar into Q3. Right? Have you all got the same equations?
Yes, sir.
Now if you observe J3 K3 I have written is equal to 1. I actually didn't write 2K maps. Really it was out of sync for you. Right? Because 1x 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 x1 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 still would end up to be the same thing because all would form one group. Okay, did you get all the 4 equations?
Yes, sir.
Okay, now it is time to write the diagram for this. How do you draw the diagram? Please note one thing. Q3 is your LSB, Q1 is your MSB. Also, one more hint, if you observe, Q3 will always toggle 10, 10, 10, 10. If this was there, this would have been 10. So this is always equal to 1. Meaning what? If you connect both J and K to be 1, meaning it works as a toggle flip-flop. Correct?
Yes, sir.
Okay. See, typically what happens here is, if this question is asked for 10 marks, okay, assume that this question is asked for 10 marks, then usually this table carries 3 marks. Okay, if you write this table correctly, you get 3 marks. For the K map, you get 4 marks. That is, for each K map, you get 1 mark. And for the diagram, you get 3 marks. Okay, so this is how typically they would split it. But there are instances that they would give lesser marks for diagram and more weightage for this table also. Now, the question that arises is, what if my table, I have made a mistake here. Instead of writing 0x, I would have written x0 ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಅವಾಗ ಈ ಟೇಬಲ್ ತಪ್ಪಾಯಿತು, ಮಾರ್ಕ್ಸ್ ಹೋಯ್ತು. ಈ ಟೇಬಲ್ ತಪ್ಪಾಗಿರೋದ್ರಿಂದ ನೀವು ಕೆ ಮ್ಯಾಪ್ ಕರೆಕ್ಟ್ ಆಗಿ ಹಾಕಿದ್ರು ಈಕ್ವೇಶನ್ ಅದು ಬರೋದಿಲ್ಲ, ಈಕ್ವೇಶನ್ ತಪ್ಪಾಗತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಅಲ್ಲೂ ಮಾರ್ಕ್ಸ್ ಹೋಗುತ್ತೆ. ಬಿಕಾಸ್ ಯುವರ್ ಈಕ್ವೇಶನ್ ಇಸ್ ರಾಂಗ್, ಯುವರ್ ಡಯಾಗ್ರಾಮ್ ಇಸ್ ಆಲ್ಸೋ ರಾಂಗ್. ಸೊ ಅಲ್ಲೂ ಮಾರ್ಕ್ಸ್ ಹೋಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
So be very careful. Remember the excitation table very carefully and do the design. Okay. Now we will draw the diagram. Now we will draw the diagram for this. How do we do it? How many flip-flops are required? We require 3 flip-flops. So please draw 3 flip-flops. And the trick while drawing this flip-flops is give considerable amount of space between the flip-flops. Okay, I will call this as FF3, FF2, FF1. So this is J1, K1 clock, J2, K2 clock, Q1, Q1 bar, Q2, Q2 bar, J3 clock, K3, Q3, Q3 bar. Okay, typically the easiest thing to do is first finish off the clock. Okay, so it is a synchronous counter, so all clocks need to be same. You can always pull this things high, Q1, Q1, Q2, Q3. Okay, see, there are 2 ways of drawing this diagram. I'm going to draw both the ways for you. In this case, this is my LSB, this is my MSB. Okay, so J3 and K3, J3 and K3 are connected to logic 1. So directly do this. Okay, now what is the equation for K2? K2 is Q3. K2 is Q3. So what do you do? Directly take one line from here and connect. See, I'm doing it here in color so that you will not get confused. But in exam, you can use only black ink. That is sufficient. Okay. K2 is equal to Q3. Similarly, if you observe, K1 is also equal to Q3. Correct? People, you need to respond.
Yes, sir. Yes, sir.
Is it confusing? No, right?
No, sir.
No, sir.
Okay. Now, if you observe, what is the input for J1? J1 is equal to Q2 into Q3. So take one AND gate. So probably I'll take one AND gate here itself. From Q2, I have taken one input. From Q3, I'll take one input. Okay. This I'll connect to J1. Okay. Done.
Yes, sir.
Now, we also have one more, that is J2. We'll see what can I use. Yes, I think I can use red for this. So J2 is equal to Q1 bar. So Q1 bar I'll take from here. Okay. Into what? Q3, right?
Yes, sir.
So this you write as clock. ನೀವು ಇಷ್ಟು ಮಾಡಿದ್ರೆ ಇಷ್ಟಕ್ಕೆ ನಿಮಗೆ 10 ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ. ಸೇಮ್ ಇದೇ ತರ ಇನ್ನ ಒಂದು ಕಾನ್ಫಿಗರೇಷನ್ LSB ಈ ಕಡೆ ಇರುತ್ತೆ, MSB ಈ ಕಡೆ ಇರುತ್ತೆ. ಬರಿತೀರಾ? ಅದನ್ನು ಬರ್ದ್ಬಿಡೋಣ. ಪ್ಯಾರಲಲ್ ಆಗಿ ಬರ್ಕೊಂಡ್ಬಿಡಿ. ಐ ವಿಲ್ ಗಿವ್ ಯು ಸಮ್ ಟೈಮ್ ಟು ರೈಟ್ ಡೌನ್. So I'll shift this up so that both should be visible. ಎರಡು ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ಇದೆಯಲ್ಲಪ್ಪ, ಔಟ್ ಆಫ್ ಸ್ಕ್ರೀನ್ ಹೋಗಿಲ್ಲ ಅಲ್ಲ?
ಇಲ್ಲ ಸರ್.
Okay. So write clock. Now J3, K3 should be shorted and connected to 1. Okay. J2, here we'll take the outputs also first. Right. Q3, Q2. Oh, I made a mistake here. This is J1, K1. Q1. Now, this is my MSB. This is my LSB. Now, what is the equation for K2? K2 is nothing but Q3 directly, right?
Yes, sir.
And also K1 is equal to Q3. Right? J2 is equal to Q1 bar into Q3. If you observe, most of my drawings are freehand writings. Even in the examination, we don't expect you to draw with pencil and scale. Rough diagrams which are legible are sufficient. Okay, J1 is equal to Q2 into Q3. Okay, you can name them FF3, FF2. ನೀವು ಇವೆರಡರಲ್ಲಿ ಯಾವ್ದು ಬರೆದ್ರು ನಿಮಗೆ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ, ಯೋಚನೆ ಇಲ್ಲ. ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಈ ತರ ಬರ್ದಿರ್ತಾರೆ, ಕೆಲವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಈ ತರ ಬರ್ದಿರ್ತಾರೆ. ನೀವು ಯಾವ್ದು ಬೇಕೋ ಬರೀರಿ, ಬಟ್ LSB MSB ನ ಹೈಲೈಟ್ ಮಾಡಿ. ಓಕೆ,
Yes, sir.
Yes, sir.
okay. Any questions, any doubts that you have of whatever we have covered now?
No, sir.
Okay, then we will wind up this session and continue in the next session. Thank you.
Thank you, sir.